you all in fluid mechanics, right? In fluid mechanics subject, first question comes in mind: what is fluid? what is what is fluid, right? Fluid is a substance that has tendency to flow or start to flow when any amount of shear stress is applied, right? Right. So fluid is a substance with tendency to flow, right? Tendency to flow, right? Or start to flow when any amount of shear force is applied, right? It's a fluid. For example, here a gas cylinder is there, right? It's a closed, right? Inside of this cylinder gas is there. Here it has a valve. When we open this valve, so this gas is a high pressure, so it will start escaping uh, from uh, from this cylinder to the surrounding, right? So this is a, it means this gas is a fluid, right? Right. So similarly, here for example, this is the shaft, right, which is rotating inside of this bearing, right? And between the shaft and bearing, here there is a lubricant, right? Generally it is a grease, right? So what will happen when this shaft will rotate? So this fluid will start deforming, right? So continuous deformation will take place in the this lubricant. So this is the also an example of fluid, means this grease, this is also a fluid, right? So gas and this is a grease, means this is a liquid. It means liquid and gas both are fluid. So the difference between solid and fluid, right? As we know, solid have a preferred shape, means all the solid have a fixed shape, right? And solids are hard and not easily deformed, right? When we apply shear force on the solid, so they will not deform continuously under shear force. But in fluid, they does not have any preferred shape. These are soft and easily deformed and deform continuously under shear force, right? Here we can see when we apply here there is a fluid element between two parallel plates. So when lower plate is fixed and upper plate, when it will we apply the force, right? So it will start deforming, the fluid element will start deforming, right? So continuous deformation will take place, right? So here fluid is categorized into two parts, right? So one is liquids, another is gases, right? Fluids are divided into two categories: one liquids, other is gases, right? Liquid consider as a incompressible or less compressible, right? What is the reason behind it? Because we know for compressible fluid means here significant change in density, right? When we apply force on any liquid, so there is no significant density change, right? So this is the reason we consider liquid as a incompressible, incompressible, right? Or we can say constant density, right? Constant rho, right? Density constant, right? And occupies a fixed volume and will take the shape of the container, right? So for example here any container is there, right? So when we will pour here any liquid, so it will take its shape, right? It may be any shape. Here it is cylindrical, or maybe conical, or maybe any other shape, right? So it will take shape of the container, right? And all the liquid have free surface. This is very important. And this free surface act as a stressed, stressed elastic membrane, right? This example we can see when we sit near any river or any pond. We will see that the insect can sit on the surface of the liquid, right? Because it is this surface act as a stressed elastic stressed membrane, right? And liquid have higher viscosity than gases. Liquid have higher density than gases, but lower density than solid. All the liquid have higher density than gases, and density of solid is higher than the liquids, but except the water. In case of water, the density of water, it's 1000 kg per meter cube at 4 degree centigrade and 1 atmospheric pressure, right? And for ice, density of ice is nearly 900 kg per meter cube, right? So this is the reason we the ice float on the surface of the water, right? So when we put ice in the water, so ice will float on the surface of this water, right? This is ice, right? So because density of ice is less compared to density of water, right? But gas is considered as a compressible, more compressible, right? When we put here piston cylinder arrangement here, so inside here gas, when we apply some force here, so this density of gas rho changes, right? Changes with the force, means here significant density change. So this is the reason we consider gases as a compressible, right? And occupies entire volume of the container, right? Here if we have any container, right, if this any shape, if we put some gases here, so it will take volume of the whole container, right? And they can flow easily, right? All gases can flow easily. Next question, what is fluid mechanics, right? Fluid mechanics is defined as the science that deal with the behavior of fluids at rest or in motion, and the interaction of fluid with solids or with other fluids at the boundaries, right? So when fluid at rest means the velocity of fluid is zero, right? For example, as we can see here this is a dam, water is there, right? So it's free surface, right? So this is the water force exerted on the wall of the this dam, and also channel and uh, gate of the dam, right? So this study is under the fluid mechanics, right? Similarly, water flow inside a pipe, right? So how much head loss, right? So this is also a study in a fluid mechanics, right? So here the interaction of fluid with solid. Here if we see here, airfoil means this is the air wing, aeroplane wing. This is the aeroplane wing, right? Cross sectional area of the aeroplane wing. So air is flowing over this wing. So what will happen? We will get some lift, right? Lift and some drag, right? Drag. So this study also comes under fluid mechanics, right? So what is the fluid mechanics? The study of fluid when it is in rest, right? And when fluid in motion, right? And the interaction of solid with fluid, right? These are the all are comes under the fluid mechanics, right? So this is the fluid mechanics, right? Also here the mixing of two or more fluid, right? For example, in a uh, sometime we need mixing of two or more liquids, right? Liquid 1 and liquid 2, right? They will mix, right? So here this study also come under the fluid mechanics. Fluid flow, right? The main objective to analyze the fluid flow is to solve the properties at each point, right? Properties like density, temperature, pressure, velocity ux, uy, uz, all three velocities, etc., right? Using the basics law, right? Basics law. For example, here conservation of mass, this is also called continuity equation, right? And second, Newton's law of motion, right? F equals to ma. Third, equation of state, right? Fourth, first law of thermodynamics. First law of thermodynamics, this is the conservation of energy, right? So sufficient number of equation to solve the properties. As we know, the for example n unknown are there. So here n equation is required to solve the, if here n unknown, so here n equation is required to solve these n unknown, right? So property, fluid property, first is the here this is a mass density. This is also simply called density, right? It is defined as the mass per unit volume. Mass means m and volume, this is represent here v, right? So unit is mass in kg and volume meter cube, so kg per meter cube, right? So density of water at a 4 degree centigrade and water at atmospheric pressure, it's a 1000 kg per meter cube. And density of air, it is nearly 1.24 kg per meter cube. and density of mercury Hg, right, it is 13,600 kg per meter cube, right. So here means it is shows the per per uh, per meter cube how much mass is there, right. For example, here 1 meter cube box is there, so how much mass inside of this this volume, right. So it's a density, right. So similarly, second is the specific weight. It is defined at weight of the fluid per unit volume, right. Weight we represented by W and volume V. So here weight means mg, mass into g. So here mass we can write density into volume. So volume and volume, this is cancel out, so we will get rho g, right. So specific weight equals to rho g, right. So here for water density it's 1000 and g it's a 9.81, so it is 9810 Newton, because we know weight unit is in Newton and volume it's meter cube, right. So Newton per meter cube, right. So and similarly relative density, right. So relative density, this is also called specific gravity, right. Specific gravity Sg, it is defined as specific weight of substance to the specific weight of water at standard temperature and pressure, right. So specific density of any liquid, right. Any liquid is a specific weight of the liquid upon specific weight of the standard fluid, it's a water, right. So G and G both are same because the sum for this is constant, right. So it's a rho upon rho of, this is the rho of liquid and this is rho of water, means this is shows the how much lighter or heavier the fluid is with respect to water, right. For example, if we know the density of mercury is 13,600 and water it's 1000, so it's a 13.6, it means the it means mercury is 13.6 times heavier than the water, right. And similarly for gases, the specific gravity for gases, we take rho of gas, specific weight of gas divided by the specific weight of air. Here we are using for gases the standard fluid, it's a air is a standard fluid. So here density of gas divided by density of air, right. This is the density of gas and this is the density of air, right. So it's a ratio. So so here these two are the ratio. So here in case of gas, air is a standard fluid and for liquid water is a standard fluid, right. Water is taken as a standard fluid, right. It's a water and here it's a, for gas it's a air. and the specific gravity, here we know, here this is density, this is ratio of density upon density, or specific weight upon specific weight, right? So it's a dimensionless, right? So the specific gravity or relative density, this is a dimensionless, right?